Hello and welcome to the Ohm's Law Lab. In this experiment, we will be looking at the relationship between current, voltage, and resistance, which we know as Ohm's Law. Now, in order to perform the experiment, what we have is an electronics lab kit. We have the source of voltage right here and current. We also have a current sensor, which is what this is right here. We have a voltage sensor, which is what this is right here. We have some sets of leads for hooking up our circuit, some wire, and also two resistors. Now the resistor here on the bottom is 10 ohms. We will be using that for the first part of our experiment. And the resistor right here is 100 ohms. The way that you can tell the difference is by looking at the colors that are on the resistor here. You'll notice that it is brown, black, black, gold. The first color would be a 1. The second color, which is black, is a 0. And then the third one is times 10 to the power of, and in this case, 0. So 10 to the power of, 10 times 10 to the power of 0, which is 10. The gold line right there that you see corresponds to the tolerance, how well this has been designed. You see gold, silver, and none typically, and gold generally means somewhere around 5% tolerance, which means that if you were to measure the resistance of this, it would be that much, plus or minus 5%. Now, this next resistor right here that you see, you can see it is brown, black, brown with a gold. That is 1, 0 times 10 to the 1, or 100 ohms. This is the one that you'll be using to repeat the experiment, with just more resistance. So these are the things that go into doing the experiment. I'm going to set this lab up, and then I'll show you what it looks like set up and talk a little bit more about how the experiment needs to be done. So this is the circuit that, as built, without any of the sensors attached to it. As you can see here, we have red, which is positive, attached to one side with a wire going over here, providing power to our resistor, which then goes back to the negative side, which then goes back to our power source. So this is just a simple series circuit. Now, I'm going to show you in the next very short video what this looks like with the sensors hooked up. Voltmeters are devices that measure voltage, and if you remember, voltage depends upon 2 points in space. So when you measure the voltage of a resistor or of a capacitor or of any other sort of device, you measure across it. So typically, one side of your voltmeter is on, we'll say, one side of the voltage that's going into the device. The other side of the voltmeter is on the other side where it comes out. So you get a difference between. Current is like water, so you measure how much is going through. So a current sensor or a ammeter is actually something that is in line with the circuit and actually measures the amount of current passing through the wire. So we'll see that here in the next video. So this is the experiment fully set up. Let me fix this wire right here, since that had pulled out there. These springs don't hold the wires very well. Were you to go off and do a more formal electronics class, you'd probably be using breadboards, which are a little bit more versatile than this. So that said, right here, this is the voltmeter. As you can see, it goes to the interface right here. And I'd like to point out here that we have a resistor right here. You have one side of the voltmeter on one side and the other. So what you're doing is you're measuring the voltage across. So when you measure voltage across right there. Likewise, current is something that you measure through. So what we have here is the current passing through our ammeter and then back out through into the circuit here. So this measures the amount of current that's flowing through the wire that, as a consequence, goes through here and goes through our resistor. So that's the experiment as set up. So what you'll be doing is you will be changing the voltage from initial to final voltage, which we'll be talking about in the how-to video here in a moment. What you're going to be doing is looking at the relationship between V and I in an effort to see what R is. You should get a resistance that in this case is 10 ohms. So what you'll do you'll do the experiment once using the 10 ohm resistor, and then you'll switch out the 10 ohm resistor for the 100 ohm resistor right here, and then repeat the experiment and just verify Ohm's law. And so this is the setup and basically how it's done. And what we'll be talking about in the next video is the theory behind it. We'll also talk about resistor color codes and, basically what's going on here. And I'll see you then.
Hello and welcome to the theory section for the Ohm's Law Lab. In this experiment, we'll be doing 3 runs. One run will be with a resistor that is 10 ohms. Another run will be with a resistor that is 100 ohms. And then your final run will be with a light bulb. Now, the resistance of your light bulb varies as a function of temperature. And that has to do with the fact that as you increase the temperature of the element within a bulb, for example, tungsten perhaps, the resistance actually increases with temperature, which means that the current is not a constant, but it is a function of temperature as well, and as a consequence a function of time. So in general, what we're doing here is we're testing Ohm's law. So, were you to look at this particular setup right here for the top circuit, the voltage that would sit across our resistor would be the same voltage that you get from the source. So, Ohm's law says V is equal to I times R. So what you'll be plotting is voltage on one axis. You'll be plotting current on another axis. And if you look at the relationship between voltage and current, for example, let's pretend this is what you're plotting right here. You've got your voltage here and you've got I here. Were you to plot this, this is analogous to Y is equal to some constant times, X being I and Y being V. So what you should get whenever you take and you plot this is a straight line. And the slope of the line is going to depend upon the resistance, since really the slope of this line would be the resistance of your resistor. Now, when you do the light bulb, what you'll notice is that you do not have a clear linear relationship between VI and R. So what you'll probably see when you plot this is going to be something that looks a little bit like this. If you plot voltage on this axis, we'll say, and current on this axis, you'll see something to sort of freehand it that looks a little bit like that, as your resistance increases, as a function of temperature. That's it for the theory section, just to give you an idea of what you should expect when you plot things, and I'll see you in the next lab.